Problem 1, a card is selected at random from a standard 52 deck cards. Find the probability that a red king is selected. I know there's 52 total cards. I know there's 4 kings, but 2 of the kings are red, 2 of the kings are black. So there's 2 favorable over 52 total, or 1 over 26. A card is selected at random from the same deck of cards. Now the question says, what's the probability that a red card or a king? So a red card or a king, well, I know that there are 26 red cards and there are 4 kings. So it looks like I have to add 26 plus 4. But remember the kings. There's the king of spades, the king of clubs. They're both the black kings. And then it's the king of hearts and the king of diamonds, which are the red kings. So actually, 2 of the kings are red. So 2 of them is counted in this 26. So I can't count those cards twice. I'm going to take the 26 red cards and I'm going to add the 2 black kings to get, as the bell rings, 28 over 52, or 7/13. Problem 3, I choose a number between 1 and 10. 1 and 10 are included. You try to guess the number. How much of a chance do you have to guess the number correctly? Well, there's 10 total outcomes. There's 10 numbers. I'm choosing one number from 1 to 10. So there's only one favorable outcome. If I choose the number 7, the only way you win is if you pick the number 7. So here your probability is letter A, 1 out of 10. Ashley throws 2 normal 6th-face dice. When you do 2 dice questions, you are going to create a dice chart where you're going to take the numbers 1 through 6, write them across the top. You're going to take the numbers 1 through 6, write them across the side, because each die, there are 6 total outcomes, 1 through 6. And now what we're going to do is we're going to fill in the 36 possible outcomes for when you roll 2 dice. So for example, you can roll a 1 and a 1 to get a sum of 2. You can roll a 2 and a 1 to get a sum of 3. A 3 and a 1 to get a sum of 4. So what you're going to do is you're going to carefully fill in all 36 of these outcomes. When you do these 2 dice questions, your denominator is going to be 36. And what you do is you then look in your chart and you see how many of them are favorable, how many of them answer the question. So in problem number 4, there's 36 total outcomes. How many of them are at least 11? Well, the 2 11s are at least 11, but also the 12 is at least 11. So there's 3 favorable over 36 total, or 3 over 36, that reduces to 1/12. I'm going to skip to number 6, and then I'll get back to number 5, because 6 also uses 2 dice. 2 dice are rolled to find the probability that the sum is 8. Well, how many 8s? 1, 2, 3, 4, 5 out of the 36, or answer choice A. Here's another 2 dice question, number 7. 2 dice are rolled. What's the probability that their sum is not an 8? Well, I know there's 36 total outcomes. There's 1, 2, 3, 4, 5 8s. But if there's 36 outcomes and 5 of them are 8, that means there's 31 of them which are not 8. So here your probability is going to be 31 out of 36. Probability is always favorable over total. Number 4, 8 cardboard boxes are standing on a table. 2 among them have a present. So I'll have my 8 boxes. 2 have presents. So I'll maybe pick this one and this one. It says your friend selects a box that contains a present and leaves the room with the present. So let's say your friend picks this box. They're picking this box, they're taking their present, and now they're leaving the room. So now this box doesn't have a present in it. So here it says you select one of the remaining boxes. What's the probability that you select a box without a present? Well, only one box has a present. That means 7 of them don't. So probability of getting a box without a present is 7 out of 8. 7 out of 8. Number 8, 10 Scrabble tiles are placed in a bag. 4 of them have the letter A. And it says 2 tiles each with B, C, and D. So there's a total of 10 tiles. 1 tile is drawn, so you have 10 total outcomes. What's the probability that the tile is not a letter in the word cat? Well, letter B is not in the word cat. Letter D is not in the word cat. So there's 4 favorable out of 10 total, and that reduces to 2 over 5. 2. Problem 9, a card is selected at random from a standard deck of cards, so there's 52 total. Find the probability of getting a red face card. Well, the face cards are jacks, queens, kings, and aces, but you need a red face card. So although there's 4 jacks, only 2 of them are red. So there's 2 red jacks, 2 red queens, 2 red kings, 2 red aces. So it's going to be 8 out of 52, and that reduces to 2/13. Problem 10. A bag contains 3 red, 4 blue, and 2 white marbles. So 4, 3, and 2 for a total of 9. It says 1 marble is selected. From the probability of selecting a blue, well, there's 4 blue marbles. So 4 out of 9, or letter D. 2 hearts are selected from a deck of cards. Find the probability that the person selects 2 hearts. Well, on the first pick, there's 52 total cards, and 13 of them are hearts. But then on the second pick, you assume that you got a heart on the first pick. Now you're down to 51 cards, and since you got a heart on the first pick, you're down to 12 favorable outcomes. So that's going to be 13 over 52 times 12 over 51, or 1/17. A combination lock has 3 numbers in its combination. You already know the second and third numbers. Find the probability of guessing the correct combo if there's 40 possibilities. So there's 40 total outcomes. You already know the second and third numbers. You know the first number has to be one of the 40, and the first number is a multiple of 3. So the first number could be a 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, or 39, because it goes up to the number 40. So it looks like here there are 13 out of 40 favorable over total. So 13 over 40. A bag contains 4 green, 3 red, 2 purple marbles. 1 marble is selected at random, removed from the bag, and then a second one is chosen. Find the probability of selecting 2 red marbles. Well, on the first pick, there's 3 red marbles, and there's a total of 9. You assume you picked one of those 3 red marbles. So the first marble is removed from the bag, which means now you're down to 8 marbles left for the second pick. And you got one of the 3 red marbles on the first pick, which means you're down to 2 favorable on the second. So here you have 3 over 9 times 2 over 8, or if you do it on your calculator, 1/12. A bag contains these same marbles, same game, but now the marble that you pick first is placed back in the bag. So the probability of getting 2 red marbles, on the first pick it's 3 out of 9, but then since the red marble is put back in the bag, you have 9 marbles to pick from the second pick, and all 3 red marbles are still there. So here you have 3 out of 9 times 3 out of 9, or 1/9 as your probability, letter A. Finally, number 15, the spinner below is spun twice. Each section is the same size. Find the probability of spinning 2 reds. Well, how many red sections are there? 1, 2, 3. How many total sections? It looks like if you count them up, there's 8. So you have a 3 out of 8 chance on the first, 3 out of 8 chance on the second, or here we're going to have 9 out of 64, or answer choice D.